Hi, and welcome back to Weekly Dev Tips. I'm your host, Steve Smith, aka Ardalis. This is episode 47, in which we'll introduce the solid principles. I'll spend a little time reviewing these principles in the upcoming episodes. What are the solid principles of object-oriented design? We'll find out after this quick word from our sponsor, devBetter. Are you a software developer looking to advance in your career more quickly? Would you find a mentor and a group of like-minded professionals valuable? If so, check out devbetter.com, read the testimonials at the bottom of the page, and then sign up for a risk-free membership if you think it's something you might be interested in. Okay, so let's talk about solid. Depending on how long you've been programming, you may have heard of the solid principles. These are a set of 5 principles that have been around for several decades, and about 15 years ago, someone, I believe it was Michael Feathers, had the idea to arrange them in such a way that they formed the macronym SOLID. Prior to that, I think the first time they were all published together was in Robert C. Martin's 2003 book, Agile Software Development, Principles, Patterns, and Practices, in which their sequence spelled out SOLDI. Oh, so close. They could have just inverted those last 2 letters. This same sequence was also used in the 2006 book, Agile Principles, Patterns, and Practices in C# by Uncle Bob Martin's son, Micah Martin. So, what are the solid principles? As I mentioned, SOLID is a macronym, meaning it's an acronym formed by other acronyms. In this case, these are SRP, OCP, LSP, ISP, and DIP. All those P's at the end of each acronym stand for principle. That's principle with an LE at the end. Listing each principle, we have single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion. You may already be familiar with these principles. If you're a developer who's using a strongly typed language like C# or Java, you should be extremely familiar with them. If you're not, I recommend digging into them more deeply. Applying them can make a massive difference in the quality of code you write. How do I define quality? Well, that's probably a topic I could devote an episode to, but the short version is that quality code is code that is easy to understand and easy to change to suit new requirements. It's easily and quickly tested by automated tests, which reduces the need for expensive manual testing. And it's loosely coupled to infrastructure concerns, like databases or files. That may not be your definition of quality, but that's the one that I generally use. Now, how do these principles help you to write quality code? They provide guidance. You need to write code that solves a problem, first and foremost, but once you have code that does that, before you call it done and check it in, you should evaluate its design and see if it makes sense to spend a few moments cleaning anything up. Way back in episode 6, you are listening to these in sequential, not reverse order, right? I talked about Kent Beck's approach to make it work, make it right, make it fast. Solid principles should generally be applied during the make it right step. Don't apply them up front, but as I discussed in episode 10, follow pain-driven development. If you try to apply every principle to every part of your codebase from the start, you'll end up with extremely abstract code that probably doesn't do anything. Don't do that. Instead, build the code that you need to solve the problem at hand, and then evaluate whether that code has any major code smells, like I discussed in episode 30. One huge code smell is code that is hard to unit test, meaning it's hard to write an automated test that can just test your code without any external infrastructure or dependencies like databases, files, web servers, etc. Code that is easy to unit test is generally going to be easy to change, and code that has tests is also easier to refactor, because when you're done, you'll have some degree of confidence that you haven't broken anything. In upcoming episodes, I'll drill into each principle a bit more. I've published 2 courses on Solid at Pluralsight, where you can obviously learn a lot more and see real code, as opposed to just hearing me through a podcast. The first one was published in 2010, and so the tools and look were a bit dated. The more recent one is slimmed down and uses the latest version of Visual Studio and .NET Core. It was just published in April of 2019. There are links to both courses in the show notes. The original course also covers the Don't Repeat Yourself principle. Neither course is a copy of the other, so you might enjoy watching both. Let me wrap up this episode with a very brief overview of each principle. The single responsibility principle is generally applied to classes, and suggests that classes should have only one responsibility, which can also be thought of as one reason to change. Responsibilities include things like business logic, UI logic, data access, and more. Following this principle, you'll tend to have smaller, more focused classes. The open-closed principle suggests that you should be able to change the behavior of your system without changing its source code. This generally relies on some kind of parameter or plugin capability to provide new behavior to an existing class or service. The Liskov substitution principle cautions against creating inheritance hierarchies in which child types are not 100% substitutable for their base types. When violated, this can result in messy code, duplication, and bugs. The interface segregation principle suggests that classes that use interfaces should use all or most of the interface's exposed members. They shouldn't depend on functionality they don't use. This then leads to interfaces that are small, focused, and cohesive, much like SRP. Finally, the dependency inversion principle recommends that low-level concerns depend on high-level concerns, not the other way around. This means, for example, that business layer code shouldn't directly depend on data access code, but rather an abstraction should exist that the business code works with and that the data access code implements. At runtime, the data access code will be provided as an implementation of the interface that the business code has been written to work with, providing loose coupling and more testable code. I have a bunch of resources on the show notes for this episode. Go to weeklydevtips.com/047 to access them, or scroll down inside your phone to check it out in the podcast description. And that's it for this week. If you want to hear more from me, go to rdallas.com/tips to sign up for a free tip in your inbox every Wednesday. I'm actually much better about sending out these tips every Wednesday as opposed to these podcasts that are kind of hit or miss in terms of how often they go out. I'm also streaming programming topics on twitch.tv/rdallas, most Fridays at noon Eastern Time. These are being archived on YouTube as well. Thank you for subscribing to Weekly Dev Tips, and I'll see you next week with another great developer tip.